In the previous video, you learned about the different permutation formulas. Now for this particular video, let us discuss about the combination formulas which deals with selecting of objects so without arranging them. So what are combinations? Combination is the process of selecting R objects from a group of N objects. In combinations, ordering is not important, unlike in permutations. For example, the ordering green, blue, and red is just the same as the ordering red, green, and blue. So these two will have the same count. So the combination formula is given as NCR, or is read as N combination R, and its formula is N factorial divided by the quantity of N minus R factorial multiplied to R factorial. So this is the number of ways of selecting R objects from N distinct objects. Okay, so you can actually get this from your calculators. Now, if ever you want to compute for 5 combination 3, then that means you just need to type in 5 and then type or press the function NCR and then followed by 3 and then followed by the equal sign. So let's have examples. In how many ways can 3 class representatives be chosen from a group of 12 students? So in this scenario, we are supposed to select or choose 3 class representatives from 12 students. Now, after choosing the 3 class representatives, there is no ordering to be imposed. So which means that this is N combination R and not N permutation R. Because in N permutation R, after you select the R objects, there should be an arrangement or there should be an ordering imposed to the selected objects. Okay? So since in this case, we're supposed to choose only and not arrange the 3 class representatives, so this will be 12 combination 3. So manually computing this, we have 12 factorial divided by 12 minus 3 factorial times 3 factorial. So this is 12 factorial divided by 9 factorial times 3 factorial. So you can just use your calculators to compute this, using the solution or using the 12 combination 3 symbol. Okay. Another example would be the Lotto system. So for example, in the Philippine 642 Lotto system, wherein a bet consists of choosing any 6 numbers in no particular order from 1 to 42, how many possible bets can be made? So in the 642 Lotto system, the ordering of the numbers doesn't matter. So which means we can use the combination formula, and it is 42 combination 6, and this is actually at least 5 million. If you will use your calculators, you will find out that this is more than 5 million selections. Okay, next is a bag contains 4 white balls, 6 yellow balls, and 5 red balls. In how many ways can 6 balls be chosen if there must be 2 balls of each color? Now, the bag contains a total of 15 balls. 4 of them are white, 6 are yellow, and 5 are red. And then we are supposed to select 6 balls from the bag. But the requirement is that we're counting only the cases wherein the 6 balls would contain 2 balls of each color. So we can view this problem, or we can view this problem using this illustration. Suppose that this is the bag, and there are 4 white balls, 6 yellow balls, and 5 red balls. So we have a total of 15 balls. And then we're supposed to select 6 balls. Okay, so we're supposed to select 6 balls. The requirement in this problem is that 2 balls of each color must be selected. So since we're selecting the balls and not arranging them, then the number of ways of selecting 2 white balls from the 4 white balls is 4 combination 2. And the number of ways of selecting 2 yellow balls from the 6 yellow balls is 6 combination 2. And then using the multiplication rule, we multiply these two combinations. And then the number of ways of selecting two red balls from five red balls is 5 combination 2. So we shall multiply this again in the first two products or in the first two factors. Okay, so using your calculators, you can determine the final answer. Okay, so that's the total number of ways of selecting 6 balls containing 2 balls of each color. Okay, now, the last part of counting techniques is counting by cases. Now, some experiments will, will have several cases. And if an experiment has k cases, then the total number of outcomes of the experiment would be m sub 1 plus m sub 2 plus up to m sub k, where m sub 1 is the number of outcomes in the first case, m sub 2 is the number of outcomes in the second case, and m sub k is the number of outcomes in case k. Now, these quantities, the m1, m2, and mk, may be obtained by using the previous counting technique formulas that you have learned so far. So let's have an example. An experiment consists of selecting a letter from the English alphabet. If a vowel is selected, a die is rolled. Otherwise, a coin is tossed. So how many possible outcomes are there? So in this problem, there are two cases. Case 1 is when a vowel is selected in the first event. And then case 2 is when the letter selected is not a vowel. So that would mean that the letter is a consonant. So in case number 1, if the letter is a vowel, there are 5 vowel letters, and each of these 5 letters will branch out into the outcomes of the die. And the die has 6 outcomes. So using the multiplication rule, we have 5 times 6 equals 30. And then for case 2, since the number of consonants is 21, this will be multiplied with the number of outcomes when we toss a coin, so which is 2. So 21 times 2 is equal to 42. Now in this case, the 30 here is M1 and the 42 is M2. So counting by cases, we have M1 plus M2 is equal to 72 possible outcomes for this experiment. And finally, we have another example for counting by cases. So in a standard deck of playing cards, 5 cards are selected without replacement. So when we say without replacement, once a card is selected, it cannot be brought back to the standard deck. No, and then once you have selected, you just keep it and then select another card. So that's what we mean by selection without replacement. So select a card and then do not put it back on the standard deck, then select another card until you have selected 5 cards. Okay, so now the question is how many possible selections would contain at least 3 queens? So in this case, when we say at least 3 queens, it's 3 or more queens. Okay, so which means that we have our first case as selection of 5 cards in which there are exactly 3 queens. And then case 2, we have the case wherein we selected 5 cards in which the 5 cards contains or contain exactly 4 queens. Okay, so these are the only cases because we don't have any case wherein there would be exactly 5 queens because the standard deck contains only 4 queens. Okay, so how do we count the number of selections in which the selection would contain exactly 3 queens? So just like in the red, white, yellow balls problem earlier, we can actually view the scenario as follows. So this circle here would represent the standard deck, the 52 playing cards. And then we have the queen cards. No, we have 4 queen cards, and then the other cards. So if the 4 queen cards are here, then the 48 other cards would be in this position. And then we are supposed to select 5 cards. we select 5 cards. So if in case 1, we have exactly 3 queens, so in how many ways can we select the 5 cards in which it contains exactly 3 queens? So that will be 4 combination 3 times 48 combination 2. No, since we're selecting 5 cards, so the other 2 cards no, will come from here. Okay, so that will be 4 combination 3 multiplied to 48 combination 2. So similarly for case 2, what we're looking for is selection of 5 cards in which there would be exactly 4 queens. So again, we have 4 queens and 48 other cards, and we're supposed to get 5 cards. So since we have exactly 4 queens in the selection, so there should be 4 combination 4, and then the remaining card would come from the other cards. So the number of ways of selecting one card from 48 cards will be 48 combination 1. So since these are by cases, now we just add the following and use your calculators to find the final answer. Okay, so now you have learned about combinations and counting by cases. So the next set of videos, we shall discuss the next chapter, which will deal with probabilities.